In this video, we are going to talk about servo motors and servo drives. As you may already know, servo motors are compact yet powerful devices that translate electrical signals into precise mechanical movements. Their applications are vast and varied, from controlling the movement of robotic arms on assembly lines to guiding the precision cutting of materials in CNC machines. Servo motors provide unparalleled accuracy and repeatability, crucial for maintaining high quality standards in manufacturing. So it's important to learn how to use them and how to integrate them into our machines. I am personally not a drive specialist, but these days these devices are very easy to work with because of the advancements in the software and overall in the hardware technologies. And in just a few minutes, you can convert some electrical signals into some mechanical movements. As you may know, there are many different options when you want to select a servo drive or servo motor, depends on the application. But in this video, we are going to focus on Siemens servo drives, and we are going to work on a particular drive called S210. During this video, we are going to show you how to configure this drive and how to write a PLC program to control it in just a few minutes. We want to make this video a complete tutorial for absolute beginners. So we will walk you through both hardware and software step by step. So again, there are too much to talk about. You can just go to different manufacturer websites. For example, here I'm on the Siemens website to learn what different type of product line do they offer. But in this particular video, we are going to focus on the integration of the drive and the PLC and how to use it. So without further ado, let's jump into the details, and I'll switch the camera, I'll show you the hardware, and then we'll open the TI Portal software. We'll configure the drive, we'll write the first PLC program, and we'll go from there. So before switching the camera and show you how the actual hardware looks like, let's quickly look at the part numbers and the datasheet of the equipments that we are going to use in this demo. First of all, this is the drive that I'm going to work with. It's a Siemens S210 drive, and it's a single phase drive, and the power rating is 0.75 kilowatts. Of course, there are different versions. You could just get a 3-phase if you need, but here I only have 1-phase voltage, so I'm just going to use one single phase drive. In addition to a servo drive, for sure we need a motor to control it. So this is the motor that we are going to work with. It's a Siemens S110 HT servo motor, and of course different motors have different power rating, and you can select them based on your mechanical requirements. The third piece to connect a servo motor and a servo drive is a servo cable, and that's pretty cool design by Siemens because everything is prefabricated for you. It's just a quick connect on one side and just quick connect on the other side, and also some simple wiring. You can start using your servo drive and control your motors with the servo drive. And last but not least, we use a S7-1500 series PLC to control the drive. One thing to keep in mind, you have to go with a T or technology CPU if you are controlling a servo motor. So that's why in this example, I'm using a Siemens S7-1500 TF. T stands for technology, F is failsafe. I don't really need the failsafe functionality in this demo, but my CPU is capable of handling that. And safety is very important in manufacturing and overall when you're working with motors and servo motors, for example, for emergency stops and so on. By the way, if you haven't checked my other video, please make sure you check that out. I'll show you step by step how to get started with fail-safe CPUs in Siemens world. So these are 4 components that we are going to use in this project. So let's just switch the camera and see how the physical hardware looks like. Okay, here is a quick look at the setup that we have here. This might not be the best looking setup that you've seen before, but I just put everything together just to make this video for you. So let's just jump into the detail and see what we have here. Because I'm in Canada and the voltage is 120, so I needed a power converter or transformer to boost the voltage to 230. That's why we have this device on the left. This is just a generic transformer you can buy from your hardware store that converts 120 to 230 230 or 240 volts. And then on the right side, we have the servo drive. That's S210 new drive. Next, I have this servo motor here. And for sure, this is not a part of the motor. I just put these marks over here so you can see how the shaft rotates. And then we have a 24 volt power supply because we need to power the CPU. And we also need to apply external 24 volt to our servo drive. And ultimately, we have our technology CPU, which is a 1511 TF that I showed you the technical data. We also have a couple modules, but we are not going to use that in this demo. So as you may see here, the motor connection is just done by a quick connection over here. I'll show you in the details how this connection is done. But overall, on the motor side, you just need to connect this prefabricated cable. And on the other side, it goes to the drive. And this one is just the encoder connector. This is the Ethernet cable goes to my PLC. And this is the 24 volt external power to the control unit of the drive. And I have my input voltage, which is a 240 volt from the transformer, and just the rest, the motor power and just the ground. So let's just quickly look at the diagram of all these connections, and then we'll open the TI Portal software and I'll show you how easy it is to configure this drive and write your first PLC program to control it. Okay, here's a quick diagram that you can find it on the motor manual. And that's normally the first thing you need to look at when you're getting a new servo drive or any kind of drive. So in the center, we have the S210 new drive, and on the bottom, we have the servo motor itself. And as I explained, you have the prefabricated cable that connects the motor to the drive. It's just a very easy way to connect the cable to the motor. You just push it in and rotate it. And on the drive side, you have the connector for the encoder. You have the connector for the motor power. That's the output from the drive, but the encoder is an input to the drive from the motor. And on the drive, there are 3 different Ethernet ports. These 2 ports are just connected together internally, and normally use the first one for connecting to your PLC, and the second port can go to another drive or another PLC or maybe your laptop. And for sure, the drive needs an input voltage. That's why we have this fuse or circuit breaker on the top, and then we have a contactor to maybe cut the power remotely from a PLC if we need to. And then we have an optional line filter, and also we have an external breaking resistor if you need that. And this drive is pretty cool because you have some digital inputs and outputs in your hands that you can use them and program them to do different things. That's it about the connection and the hardware. We'll just jump into the TI portal and we'll start from scratch. You will see it doesn't take more than a few minutes to commission a drive and write a program from the PLC to control it. Let's jump into the TI portal, commission the drive, add a program to your PLC, and let's run the motor by some command from the PLC. I like to get it started from scratch because I believe that's how you learn better. You have 2 ways. First of all, of course, you can go and manually add your drive and CPU and so on, and then write your code. But the beauty of TI portal is it's very intelligent and smart. It automatically detects the hardware and it saves you a lot of engineering time. To show you that, first thing you can do, you just create a new project. Let's just call it S210 Block IoT. Just save it somewhere. Okay, once your project is created, you can switch to the project view. And as you can see, the project is blank. There is no device or no program, no hardware or software configured here. The beauty of TI Portal is you have this online access option over here, which browses every device that is connected to your network connection. So here I have my network card. I just click on Update Accessible Devices. And now the TI portal is scanning my network connection to see what hardware is connected. It detects all the HMI, PLC, drive, and so on. So as you see, the scanning is completed. The TI portal correctly detected that a PLC and a servo drive is connected to my computer. I can just go over here and expand it. Of course, if you just want to do some diagnostic, you don't have to add it to your project. You can just go to online diagnostic. But for now, I just want to click on this servo drive, right click and just say upload device as a new station, and that's the engineering efficiency in TI portal. So as you can see, the TI portal is detecting what motor, what servo drive is connected to my machine, and it automatically adds that device to my project. So let's just wait for a few seconds. It's just loading the configuration from the device, and as you can see, in just a few seconds the drive is added to my project. And we can just go to our hardware configuration. As you can see, it has my drive and also the motor. Again, you are using TI Portal. It's very smart and intelligent, so take advantage of all these features. Okay, now the drive that is added to our project, the first step is going to rotate and optimize. And for sure, you need to go online with the drive because we are going to bump the motor or rotate the motor. So as you can see here on the lower right side, you have a live view of the motor, and please pay attention to the shaft and the movement and any error that might occur on the drive or the PLC. So after opening rotate and optimize, click the activate. Just give it a monitoring time. The default 2 seconds is good enough, and give it a predefined speed. We just give it 60 RPM, that's good enough. And then you click on the one of the forward or backward. And as you can see, my motor is moving or rotating, and that's a good sign. It means my drive is healthy, all my wiring has been correct, and we are ready to go to the PLC side. Feel free to play around with it. You can just forward or maybe backward, or even stop. If you want to jog backward, change the speed. And so on. Once you made sure your drive is configured correctly, just deactivate the access. You can configure your PID parameter within your drive automatically. You don't need to manually do that. So to do that, we go to one button tuning. Again, you need to activate the master controller, the drive. Same, give it a monitoring time. And you can select different ways to do that, but for now we just leave it for default. I'll just give it a 360 degrees, maybe just to limit the rotation of the drive, and hit the start. And as you might hear the noise, it's just adjusting or tuning the PID control. And voila, as you can see, it has significantly adjusted my integral time or the parameter I in my PID control. That's the optimized value for the PID control for this configuration. So after doing that, just deactivate the drive and make sure you hit this icon over here to retentively save the drive parameters from the TI Portal to the drive. Okay, that's it from the drive side. It's just drag and drop from the online access to the project. Our drive is ready to be controlled from the PLC. So let's just add a new PLC and then write the function blocks and the code to control the drive. Add the new PLC. I always go to add new device. I go controller. TI Portal gives me that option to detect my hardware automatically. So why not taking advantage of that? So I just go unspecified CPU 1500. I select the whole family and make sure the firmware matches and hit the next or OK. So once you have added an unspecified CPU, you will get this white CPU, and you can just simply detect it or select it from hardware catalog. If you have access to the hardware, for sure, just go with the detect. So the TI Portal detects what hardware is connected to the TI Portal and brings the information to the project. So start search, and it just instantly found out that the CPU 1511 TF-1 PM is connected to my computer or programming unit, and I just hit detect. I approve, it just connect. So once you add a new PLC you might be familiar with, you just get this PLC security setting. For demos, we never activate any security such as password because we don't want to punch in the password every time we download. And we'll just grant the full access to the project and hit the finish. And as you can see, the TI Portal has automatically detected my CPU and everything else that is connected to that CPU. And as you can see here, I have a digital input module and also a digital output module. Now we have the PLC in our project, and also we have the S210 Servo Drive in our project. We can go ahead and start writing the code in the PLC to start controlling the drive by our own commands. So first thing first, When you add a new PLC, make sure you assign the correct IP address for it. Make sure there is no IP conflict with other devices in your network. But for now, because I'm using something that I've already used, it has already the correct IP address. And here I'm using 192.168.113. And you can also customize your Profinet name, but you can just leave it as generate Profinet device name automatically by TI Portal. But in real life project and production, it's always good to put a meaningful name for every Profinet device. So we can just switch to the device and network because we want to make a connection or Profinet connection between the drive and or PLC. We can just simply click on not assign and select this PLC as the master controller, and you can also go to the topology view, as you may know in TI Portal, and connect the right port, the right PLC port. So there are just a couple important settings that you need to do on the drive and also on the PLC side before you start doing the programming. The first thing on the PLC side, you just need to open the properties of your Profinet interface, go to the advanced options and real-time setting, and you need to define what is the role of your PLC. So here we just want to define it as sync master. That's the typical configuration when you are connecting a PLC to a drive. Just save your project, and that's all the setting that you need to do on the PLC side. Let's just go to the drive and then select the Profinet port. Under the telegram configuration, select the device control telegrams, and make sure the Telegram 105 is selected. In general, Telegram is just a standard way to communicate between Siemens Drive and the PLCs, and each Telegram has its own meaning and you can use them for different purposes. For example, for this demo, Telegram 105 has all the information that we need, so we'll just leave it as a default. Okay, so here, first thing we want to do, we just select under the organization block, and as you can see, we don't have any organization blocks, so just hit the create, just give it a name, the OK, and then you need to repeat this on the receive side if it hasn't been selected automatically. So overall, every servo drive needs to have an associated organization block. You don't really need to be worried what's going on in this OB91. All you need to know is every drive is associated with one of these organization blocks for internal processing, let's say. Okay, now our drive and PLC is ready, and we can start programming our PLC to control the drive. So first thing that you need to do, you just need to go under the technology objects, add a new object. And as you may be familiar with Siemens PLCs, technology objects are objects that do different things. One of the main objects is motion control. And of course, you can use the PID control also. That's also another technology object. But for this demo, we go with motion control. And you have different options. Based on the application, you might select the synchronous axis. You might have, if you have an external encoder, if you want to do the cam, measurement inputs. But for this demo, we just want to control the position of the shaft based on some commands that we send from the PLC. So we just select the technology object, positioning axis. You can give it your own name, but I just leave it as default and I hit OK. Okay, as you can see, a wizard will be open. There isn't really much that you need to do here. Everything has been pre-configured for you, but as you can see, you just need to correct the errors on this red side. So first of all, you need to select your drive, because in real life you might have too many drives, so you need to select which drive this technology object is associated with. So I just select my only drive in my project, and always confirm on the encoder side is also connected to the right one. And as you can see, everything has been turned green. But just to confirm, you can just walk through different menus to see what's going on. For sure, the Telegram, we have selected Telegram 105. We just leave it as default. And one of the important settings that you need to change here is going to basic parameters. And by default, the motion or the axis type is linear. But in our application, we have the rotary axis. So just select that. Okay, that's all. Now we can compile the software and hardware of our PLC and the drive and download it to the device. So as you can see, we don't have any errors. Let's just compile the software as well. Okay, no error. So we can just download the project to our PLC. Okay, after downloading your CPU, always do a download from the TI portal to the drive as well. Do a load. Okay, so the most important one, make sure this option is checked. So save parameterization retentively, because you want to save all the parameters to the drive permanently, and hit the load. Okay, now we are almost done with the drive. We don't need to work with the drive from this point. Of course, if you want to do advanced things, you want to change some parameters, you can just go back to the drive in your project. But all we need to do from this point, we just need to add different function blocks to control the drive. So to start the programming, we'll just open our main block or organization block 1 or OB1. And on the instruction palettes, you have a section called technology. And under motion control, you have different options, and different function blocks do different things, but there are some of them that are common for any application. For example, power, reset, home, halt, and so on. For using these function blocks, it's always good to keep the project organized and clean. That's why we have this data type or PLC data types, which are custom data types that you can create to make things easier and organized. For example, I want to create a UDT or PLC data type that includes different commands and feedbacks from the drive in one place. So I just simply open the PLC data type, just go add new data type, and I start filling this up. So first of all, just give it a meaningful name. I just go S210 access control, and I start typing my variables. So the first signal that you need is just enabling the access. You want to be able to reset it. You want to be able to home it, halt or stop it, and you want to give it a distance that you want to travel after giving the command, and the data type would be real, and so on. Okay, so our PLC data type is complete. Pay attention to the data types. We need a few Boolean variables and also some real or floating point variables for distance, position, and the velocity. So we can just save this, and now we can go and add a data block to use this data type that we just created. So let's just call it S210 DB, and for the type, select the UDT or PLC data type that we just created, and you can just save the project. Now we are using the motion commands or technology commands from the instruction palette. So as I mentioned, you need to use a few of these function blocks, and the first of all is the power and so on. Let's just add a few networks. A network is a section of the program, and it's just a good way to organize your project, and it's easy for troubleshooting and management. So you can just add a comment on each and so on. So the first function block that we want to add is the power. Just give it a name. So everything is almost ready for you. You just need to select them. For the access, we only have one access. Select your access, and now we need to select our enable signal, and we go to our data block and we select the enable. And that's it for the power. We need another function block called reset. Same, you can just even copy and paste this access because it will be the same for all of them. And for the execute, we just connect it to the signal that we have in our data block. The next one is home. Again, same access. Let's do 10. Next one is halt. These are 4 function blocks that you need in almost every motion controller technology object. The next one, we just want to test a few things, and for sure we want to have the move absolute. Okay, and we go move relative as well. Just connect it to the execute command. Relative, just want to double check here. Absolute, okay. And for the distance, we just go to our data block again. And also we can just add the last one, which is the velocity. So basically we control the velocity of the movement of the motor by using this command. Now we can just compile the project. Okay, let's just do a quick download. Okay, as you can see, our project has been downloaded to the CPU. The CPU is green, which means there is no error, and I went online with my project. And just a recap, you can just open your function or function block or organization block and hit this icon, and then you can monitor in real time what's going on in your CPU. We can just go here and basically change the values from different function block, but just to make it easy, I just went ahead and created a watch table and basically added all these variables in one place, so I can just quickly change them as a one single table. It's just easier to track and basically follow. Okay, I just go online. The first thing you want to do, you enable the drive, and you can perform a reset. Always it's a good idea to do a reset. Okay, let's just start with the velocity maybe. So we just want to move the drive with a predefined velocity, which could be 20. Let's just write the values. Now if I just send the commands to start the velocity, as you can see on the camera, the motor has started to move, but let's just make it a little faster. You can just go back to the OB1 also and monitor what is going on, but again it's the same thing. I prefer to look at the watch table instead. And on the feedbacks, as you can see, you can have the actual position, actual velocity, and actual speed of the motor. Okay, to stop, you just enable this halt. Okay, the next thing what we can test, start relative. So pay attention to the arrow position on the shaft, which is pointing upward. So we just want to move the drive or the shaft 90 degrees to the right. So let's just give it a start relative command. As you can see, the shaft rotated 90 degrees. So let's just do it again, and we want to move it another 90 degrees. So in total, we went from 0 degrees to 180. So we can just repeat this process if that's the movement that we desire. And for sure, you can just go the absolute position. Let's just go 45 degrees. Okay, as you can see, the shaft has been rotated to 45 degrees. Let's just do another move to go another 90 degrees forward, which is relative. I do one more time, I do a few times. Okay, again, this is just a basic getting started. For sure, there are too much to talk about servo motors, but as an automation engineer, at least you need to learn them, how to integrate in your PLC and then how to control them. So that's it for today's video. Again, just feel free, if you have the hardware, you can just explore and see how things work. So in the next videos, maybe we use this setup and control it over MQTT or add an HMI to, instead of sending these commands from the watch table, we want to control it remotely from our phone or HMI or SCADA or any IoT dashboard. So I hope this video was useful for you. And feel free to comment and send me a message if you have more questions. Until the next time, have a great day or night.